Now we are going to discuss about thermodynamics. Very useful for set chemistry, HSA chemistry or physical science, and KTET, CTET, and all other കോമ്പറ്റിറ്റീവ് സയൻസ് എക്സാംസ്. നമ്മളുടെ പ്രധാനപ്പെട്ട പോയിന്റ്സുകൾ മാത്രമാണ് ഡിസ്കസ് ചെയ്യുന്നുള്ളൂ. പോയിന്റുകളാണ് ശ്രദ്ധിക്കുക. തെർമോഡൈനാമിക്സ്. First law of thermodynamics suggests the direction of different forms of energy. Different forms of energy means rotational energy, vibrational energy, etc. etc. Second law, direction of chemical change. Third law, to evaluate entropy. The next condition, open system. So exchange both energy and matter with surroundings. Closed system can exchange energy but no matter. Isolated system can't exchange both matter and energy. Extensive system independent of the quantity of matter present. Example, temperature, pressure, density, etc. Intensive system depend upon the quantity of matter present, mass, volume, specific heat capacity, entropy, enthalpy, free energy, etc. Isothermal, which means in this case temperature constant. Isobaric process, pressure constant. Isochoric process, volume constant. Adiabatic process, no exchange of heat between system and surroundings. The next condition is Zeroth Law of Thermodynamics. Here, the recording of temperature of a system by a thermometer is based on Zeroth Law of Thermodynamics, considered as the law of thermal equilibrium. Internal energy, sum of all types of energy possessed by the atoms, molecules or ions. It is an extensive property, depends upon the amount of substance. Work is equal to pressure into change in volume. Work done by the system is equal to negative, that means expansion work. Work done on the system, positive compression work. First law of thermodynamics, conservation of energy, neither created nor destroyed but can convert. Delta U is equal to Q plus W, where Q is equal to heat. Delta U can be determined by bomb calorimeter. For isothermal reversible change, Q is equal to negative, that is pressure is equal to Vf minus Vi. For isothermal reversible change, Q is equal to minus V. For adiabatic process, Q is equal to 0. The next condition is heat capacity. Quantity of heat required to raise the temperature of the system by 1 degree. C is equal to Q divided by delta T. Heat capacity proportional to amount of substance. Heat capacity of 1 mole of substance is called molar heat capacity. Enthalpy, total energy stored in a chemical system at constant pressure and temperature. H is equal to U plus PV. Delta H is equal to delta U plus delta nRT. Delta H can be measured by ordinary calorimeter. Exothermic reactions. Evolution of heat energy, enthalpy of products must be less than enthalpy of reactants. Delta H is equal to enthalpy change is equal to Hp minus Hr is equal to negative. Next, endothermic reactions, absorption of heat energy. Delta H is equal to Hp minus Hr is equal to positive Hp greater than Hr. Standard enthalpy of formation of an element in its most stable form is taken as 0. Enthalpy of combustion is equal to negative. Hess's law. The enthalpy change in a chemical reaction is the same whether the reaction takes place in one step or in several steps. Applications of Hess's law: determination of enthalpy of reactions, determination of enthalpy formations, calculation of bond enthalpy. The average of bond dissociation enthalpy is called bond enthalpy. Then spontaneous process and non-spontaneous process take place by itself without the help of an external agency, which does not take place by itself is called non-spontaneous process. Entropy measures the disorder or randomness of the system. Extensive property: SI unit joule Kelvin raised to -1 mole raised to -1. Delta S is equal to Q by T. Delta S is equal to 0 for an equilibrium process. Second law of thermodynamics introduces concept of entropy. During every spontaneous process, entropy of the universe increases. Third law proposed by Nernst. At absolute zero, the entropy of a perfectly crystalline substance is zero. Entropy greater than zero gives free energy G. G is equal to T minus Ts. Maximum amount of energy available to the system that can be converted to useful work. The decrease in free energy is the measure of non-expansion work done by the system. Delta G is negative for spontaneous process. At equilibrium, delta G is equal to